a really cool tool that we have, our Alpha mobile unit. We actually have an entire treatment plant on wheels. Essentially, we're able to drive it right up to a wastewater treatment plant, take that water that's usually released in a stream and clean it to potable grade drinking water right there on site.
Hello and welcome to Insiders. I'm here with Jessica O'Leary from Water, who has a long history in water sports and surf park space. Jessica, welcome.
Thank you, Jess. I'm excited to be here. Let's talk surf parks.
Sounds good. Could we maybe start with just a little bit of background on how you come to be in the place you are today?
Absolutely. I've been working in aquatic recreation and specifically water sports for a very long time. I started in the wakeboarding industry, snowboarding industry, dabbled a little bit in power sports, and then came back to water with surf park development and surf park technology representation. Now I am working for an innovative water purification company that has amazing potential in the surf park industry. So just excited to share and shed a light on what we're doing differently and kind of how that can impact the surf park world.
Fantastic. Yeah, we heard from Kevin Gast, son of originator of the technology, Dr. Kevin Gast, at Surf Park Summit several years ago, and the potential seemed huge. I couldn't quite get my head around the technology, but it did seem like an incredible application, maybe even a bit before its time at that point. But it feels like we're in a place now where we're probably ready to hear about this. So can you perhaps give me a little bit of background on what the status quo for cleaning water in the surf park industry is right now and why, if at all, there's a need for change?
Yeah, there hasn't been a tremendous amount of innovation in traditional aquatic recreation filtration, right? We're looking at, there's still a lot of facilities that are using big sand filters, um, regenerative media filters. All of these take up quite a bit of space and require a lot of manual interference and chemical dosing and mixing. A lot of the code also has been written around this in the past. And admittedly, when talking to a few riders that contributed to the CDC, to the Model Aquatic Health Code, hasn't been revamped since like the 80s. So we're really moving and grooving off of kind of an old set of standards and equipment that also matches that. So I would say you're typically seeing those sand filters and regenerative media filters, heavy chlorine dosing, acid, different types of softeners that are kind of compiling our surf park mix right now.
Okay, great. Now, we'll come back to some of those components of, let's call it standard filtration techniques as it relates to sustainability and kind of what those chemicals mean, what the backwash process means for water conservation. But for right now, some of those chemicals that you mentioned, the dosing with chlorine, there needs to be a residual amount in the water. What makes chemicals like those harmful for the users of these bodies of water?
Yeah, chlorine for a long time has been the lesser evil, but there are a number of studies that are out there that show the harmful effects of chlorine. For one, chronic asthma. I mean, anybody that spends time in chlorine has experienced red eyes, dry skin, your hair smells like chlorine for the next 2 weeks. And that's, and you're going into different types of environments where the dosing is not consistent. More often than not, in aquatic recreation, they're overdosing. So increasing the chances of those negative results that chlorine can have on your body. Actually, there's a John Hopkins research report that came out talking about 12 liberated carcinogens when chlorine is used to disinfect potable water. So we now know we're being there's carcinogens in the water and there's all these other harmful effects on the human body. Then, we also have negative effects on the environment and in the surf park world, very negative effects and corrosive qualities on surf park equipment. which is most of the time utilizing iron and those types of metals.
I see. Now, you mentioned the sand filters, regenerative filtration, regenerative media filtration. Um, does that involve all of these same chemicals as well, or are these types of filtration and water cleansing less harmful?
Between sand filters and regenerative media filters, I
Yeah.
think that the chemical mix is that can be slightly different, but overall they're still utilizing a lot of the same chemicals. It's just the footprint. I know if you're not space constrained at all, it's typically the case that you can get away with a sand filter, but it's huge. It's probably like 2 or 3 times the size of one regenerative media filter. So there's more efficiencies in space. But as far as I know, there's a little bit less manual interference too with the regenerative media filters. But we're taking, filtration. Well, we're removing filtration in general, and we're taking it to a place that's completely autonomous and hands off, which is pretty exciting.
Right. My understanding is that the sand filtration requires significantly more water to, I mean, there's a water wastage component with backwashing. Is that right? Compared with other technologies?
Yeah, no, absolutely. That is a really good point. There is a lot more water lost to waste with the sand filters than there are even with some of the new regenerative media filters.
Okay. Now, you're talking about doing away with the filtration altogether, and that's kind of where Kevin Gast lost me a couple of years ago. Can you perhaps explain in layperson's terms here what makes water's technology different? I mean, what is it? How does it work? How's it different?
Well, first of all, I've been coming from the same space as you, and I was a bit in over my skis when I got started learning about the engineering behind this process and the chemicals and the science. But it's really been pretty captivating in the last 8 months that I've been with water, and super exciting to learn about. So, really, I'd say the kingpin of our technology is our proprietary ALTEP technology. And ALTEP stands for Advanced Low Tension Electroporation Process. So, we are utilizing electroporation to eradicate bacteria and microorganisms and pathogens found in water at the cellular level. Um, Electroporation, we didn't invent it. It's been around for a very long time. There's actually white papers from NASA on it, Stanford, but historically, it's always been very electrically intensive, which is why it's been reserved for those types of specialist organizations. Um, but where we really crack the code is the low tension aspect of ALTEP. So we're able to achieve electroporation at very, very low voltage, which allows us to commercialize this very effective way of eradicating bacteria. So that is how we're cleaning water. Layman's, we're essentially destroying bacteria with electricity. But in so little electricity, I think you'd be shocked.
So I'm envisaging this as one of those purple lights that I have around my house to zap the mosquitoes as they get drawn to it. I mean, I'm assuming that's not a great analogy, but how does the body of water, as in its entirety, get treated by this process?
So it's going to be similar to traditional filtration methods in a turnover time. So there's influent and effluent valves, right? So the water is first introduced to our Faraday reactors. This is where the secret sauce happens. This is where ALTEP occurs. So water enters into the Faraday reactor. That's where it's treated with the electricity, probably very similarly to the visual you just described, the mosquito zapper at your house. But instead of zapping mosquitoes, it's killing everything at the cellular level in the water. And that is so much more effective. Well, I'll get into the effectiveness later, but that is what's happening. And then it's moving out of the Faraday reactor into various, first, next it hits our separation unit, which we call the ADAF, where we're removing all of those dead cells, the debris that we just chopped up in the in the ALTEP process. We're removing all that from the water and we're taking pure water onto the next process where we're utilizing air and turbulence to buff up all those H2O molecules and get them back to shining again. Where then, depending on how strenuous your process is, it may enter another polishing unit before it's released back into your surf park. And I say that because we're working in some really large industrial spaces as well. We actually have technology that purifies wastewater treatment discharge to potable grade drinking water. So that's where, the strength of our technology really, is easier to see. When we're talking about surf parks, it's relatively clean water to start with and ultra clean water to end with.
Now, the polishing process, and I'm wondering how this happens with um, human wastewater effluent that gets turned into drinking water as well. By polishing, is that you're talking about removing these residual dead particles? Is that through a filtration process, or is it flocculation, or how does that work?
It's actually a combination of flocculation and precipitation in the ADAF unit. We're
Okay.
literally cutting the good water out of the middle, and that's moving on to the next stage, where I imagine it to be kind of like in our polishing unit, like almost a cyclone, because we're adding air and circulation and spinning it, which is buffing the water molecule.
Is the kind of reasoning, is there some kind of centrifugal reason for spinning out solid bits from the pure water, or?
Well, we're just completely eliminating the introduction of chemicals throughout our whole process. So I actually
Mhm.
wish we call it something different than a polishing unit, because that's the same type of term that's utilized with traditional filtration. But that's the part of the process where they're adding new chemicals to offset pH or to soften the water. So it's essentially what's bringing it back to its bright, clean, clear crystal characteristics.
Got it. So how does this LTEP grader process, how does that remove the need for residual chlorine? Because I'm imagining like the normal turnover time with a filtration system has a requirement for residual chlorine to kind of knock out anything that happens to be growing in the water or lands in the water or gets thrown up into the water or however it gets contaminated. How does your system eliminate the need for that?
We are, like I said before, completely eradicating everything in the water. So we're creating a very uninhabitable environment or hostile water environment for bacteria to live and grow.
That's equally effective with amoebas as well as bacteria?
Yeah, actually, we are more effective at killing fatal amoebas, Giardia, Cryptosporidium through our Altep process than any amount of chlorine is. And that's also true for UV. UV is really great technology, but with any light, you're casting a shadow. So if you hit bacteria, there could be bacteria behind it that's not hit by the UV lights. That's why it's not quite as effective. With Altep, we're killing everything. We're chopping it up at that cellular level, where chlorine is almost, for a lot of bacteria, it's great, but for the exotic bacterias, it's a hope and a prayer that you're penetrating those very thick cell walls or straining them out secondarily through filtration. We are more effective at killing that brain eating amoeba in the Altep process.
That's where I was going with that because I think that is kind of the boogeyman of large bodies of water in which people recreate, and then um, does is water also responsible for the flow of water around these lagoons and bodies of water? Because my understanding is that can be the problem is if you have pockets of kind of immobile water, particularly in warm environments for long periods of time that are not being put through a filtration process, even when there is residual chlorine, that's the environment in which those brain-eating amoeba can come into being and cause devastation.
Yeah, we're working with surf park manufacturing or surf technology manufacturing engineers hand in hand when we're designing their purification technology. So taking their existing reticulation plans and ours and marrying them between our aquatic engineers and civil engineer teams to make sure there are none of those dead pockets, that we are getting really good circulation through the water. And ultimately, if we're doing that well, it's also going to create more efficient water purification. So there's a lot of benefits to us working hand in hand at the front end. We are a little bit more hands off for sure with surf parks because there's a lot of very important elements to creating perfect waves and bathymetry and location of our inlet and outlet valves. But I think we've come up with some pretty cool solutions that ensure that.
Excellent. Now, we mentioned before some of the inefficiencies around water and with backwashing requirements for other filtration technologies. You've talked about the sheer size of some of these units that need to be installed for bodies of water this size. I can only imagine that that involves quite a bit of energy as well. I'm wondering how water's technology compares with existing technologies from a sustainability perspective. So that would include water conservation, energy usage, and harmful chemicals being released to recreationalists and then also the environment. How does that compare across the fields?
I think that's one of the things I'm most excited about here at Water is we are so supremely focused on sustainability. And there are a lot of aspects like you mentioned. With our system, we have dramatically less waste, water waste. With sand filtration, with regenerative media filtration, you have a lot of backwashing that does occur to clean the water, but it essentially does result in wasted water. We have a lot less of that. We're able to reduce our waste, or at least our water capture increase our water capture to around 98%, reducing waste to a much, much smaller threshold. We're also much more energy efficient. I was chatting with our engineers last week, actually, because we're working on a proposal for a surf park. And a lot of the surf parks kind of fall in the same range of around 2 to 3 million gallons. I mean, there are some in excess of that for sure, and some less than. But in that 3 million range, we're able to treat that water at less than 32 kilowatts an hour, which is a pretty significantly low level of electricity consumption, especially when you're looking at surf parks in general. So that's a great benchmark there. And then that 3 million gallons, we'll get into profitability later, but there are so many chemicals that are introduced into the water to keep up a parts per million of chlorine. In terms of consumable costs, that's very significant, but also just in actual chemicals that you're dosing into the water, you're managing, you're buying, you're storing, you're utilizing time and time again, over and over again. It's we're completely removing that from the equation. So much, much more sustainable when it comes to removing the chemicals.
Excellent. You talked about water capture at the beginning of your answer there. I'm actually not sure what that means in the context of water filtration. What does that refer to?
So I guess it's essentially like the water that's utilized for backwashing is water that's lost. That's water that's not going to make it back into your surf pool and ultimately needs to be replenished. We don't need backwashing to that extent. We're able to keep about 98% of that water that's coming in, purify that and release it out. I mean, you're always going to have factors like evaporation and bather load that are, that calculate how you need to replenish your pool, but we're able to bring down that backwashing and waste that happens in the filtration process.
Excellent. Maybe now we can talk about costs. And you and I have had previous conversations about some of the pretty innovative ways that water is bringing water essentially to users like surf parks. Can you talk to me a little bit about the approach that you're taking and what it might mean for helping to get portions of a surf park funded for rising costs in different areas?
Yes, yes. I'm actually so excited to talk about that. There's not a lot of people that know we're doing this, so it's important that they know it. It's not a surprise to you or I or anybody who might be watching this podcast that funding is one of the greatest challenges in the surf park industry due to its novelty. There's pretty intensive capital stacks that we're looking at as a developer when you want to build a surf park. And more often than not, people are more focused on surf technology. You know, it is what's going to make people come to your surf park. It is going to determine the types of waves and those fun objectives. But water purification tends to get pushed to the back burner. They're like, they know they need it, but they're not 100% focused on what it's going to cost and who they should go with. I feel like it's a secondary option. And I think most of the time people are shocked at the cost of what their water purification is going to be and how that affects their capital stack. Water has a really unique water as a service financing plan. And what we're able to do is require only 10% down of the surf park developer to begin their process, take them all the way through schematic design, construction documents, the completion of their project. So they have all of their water equipment in a room, commissioned and running. So 10% down to the completion of the project. And then we're able to roll up those overhead costs into a monthly OPEX, but we're also providing a service with that. 24/7 remote monitoring and maintenance, service visits, and essentially we are providing clean water as a service throughout the duration of our partnership. So it's really easy to quantify the ROI on a monthly basis because you're getting your clean water and you're getting the servicing. So you're able to pay off your water filtration equipment or your treatment equipment over time. So thus reducing the capital stack quite a bit.
Yeah, I mean that was the part that it almost like taking out a loan on your filtration, but it comes with a guarantee of service throughout the life of the project. Is that kind of how we should look
Exactly.
at it?
Yes, exactly. I was just visiting one of my buddy's new surf parks last week, and we were taking a look through, the chemical room, and there's still so much hands-on maintenance required. As far as I know, most filtration um, competitors or other service providers essentially are giving you your equipment and they're teaching you how to use it, but it's up to you to make sure that you're using it properly through the life of your park. We are eliminating that headache because it's a fully intelligent autonomous system that we are responsible for delivering the clean water. So you go with us and you're going to have clean water, or else we're going to take care of it. It's no longer something you've got to worry about as a developer.
And maybe can you talk to me a little bit about the size of water and parent companies? Because my concern would be, well, if I'm taking on this longer term investment with you guys and you're going to be responsible for the provision of clean water for the life of my project, how do I know you're going to be around for the life of my project? And I guess I'd be looking at, okay, well, what is water? Can you tell me a bit about the background and why maybe I would feel less risk knowing about the company?
Yeah, no, I think that's wise, and a lot of people are considering that when they're doing their due diligence, as you should. We are a spinoff of a 65 plus year international conglomerate called Gas Global. And essentially, over the last 65 years, Gas has become an expert manufacturer in waterproofing materials, from waterproofing paint, watertight integrations between different materials, to geosynthetic liners and different options that have been utilized throughout various industries. So we have a pretty substantial international footprint and have worked on over 14,000 projects around the world. So you are getting the strength and power of Gas Global with water. Water is their first US-based entity. that is primarily focused on this innovative and disruptive water purification technology. But in all cases, we're getting the benefit of our background in waterproofing materials and the strength in our financing and our service resource teams um, by working with us.
Sure. Yeah, I think I'd probably be reassured by the size of the parent company that's behind things there. With the rollout of I like SaaS as an acronym, but I'm not sure about WAS. But water as a service, is that the servicing of that going to be something that you guys manage in house, or would you be kind of subcontracting out for people to work with people in different geographies?
Yeah, like I was mentioning before, we do already have a pretty substantial international footprint of service providers. So we are relying on them. If there's a situation where we, have a need, we're going to continue growing that team with local subcontractors. It is a new technology, so you can't just come in off of doing something similar for a long time and know how this works. So we do need to rely on our expertise when setting up these Faraday reactors, since it is a newer process. And that is something that they take into account. But a little bit of both, I guess, to answer your question.
Okay, great. Finally, how's the pipeline looking? How confident are you guys that we'll be seeing Alteps and Faraday reactors and water as a service in the surf park industry moving forward?
Well, I'm very elated to say that we do already have some service contracts with surf parks that are in development right now. So very soon, you should see some in your neighborhood surf park. And we are working in pre-development stages with a number of others around the country here in the United States and around the world. So I think that we're going to start seeing a lot more Faraday reactors and Altep process in the surf park industry very soon.
Excellent. Any closing thoughts, Jessica? We've pretty much gone through the things that I was unsure of, having kind of been lightly introduced to the concept previously. I'm feeling pretty good about it. Is there anything else you'd like to get across?
It's important to educate yourself, not necessarily just you, but everybody to educate themselves on the, the cost benefit analysis here, right? And on these chemicals that we're introducing into our parks. Like, I think because it is so paramount to the success of your business, you can't be shut down, right? If there's an outbreak in cryptosporidium. So, the default position is let's be as safe as possible. Let's dump all these chemicals into our water and we should be fine. We'll be able to operate. But I think that there's not enough attention to the harmful characteristics of those chemicals and these alternative disinfection methods. There's this common belief that residual chlorine kills bacteria on contact. And that's not really the case. It has to be a perfect blend of, um, you know, the type of bacteria, the temperature of the water, the amount of chlorine in the water that impacts the destruction time. If it's a 3 to 4 parts per million average, you're still looking at 10 to 15 minutes before that bacteria is killed. In some cases, that's hours for something like Giardia, and they can't even promise that bacteria like Cryptosporidium can even be penetrated by chlorine at all. So what I'm kind of getting at here is people have this fail-safe option of let's just add more chemicals, that's going to protect me, but it's not really true, and there's a lot of scientific data behind that. So lean into innovation, be a sustainable leader in your surf park. I'd love to talk with you more about how you can do that with water purification technology. It's going to transform our industry because it's already transforming a lot of other industries around us, industrial, wastewater treatment, and these big major things that we need, as a society. We need clean water. So obviously that's going to apply to clean water in your surf park.
Excellent. Where do you see things? Because what that makes me think about is kind of the changing regulatory environment. And the sustainability certification that we run here out of San Diego State that includes surf parks definitely has sections on introducing chemicals that are necessary or not necessary. The most that you can reduce those is definitely a good thing. You mentioned on-site storage and handling before. There are also issues when you have toxic chemicals. Where do you see the regulatory environment heading? Because it feels like it's starting to shift around these issues.
In all standards and codes, they have to allow for innovation. Otherwise, we'd still be riding horses, right? I mean, things have to grow. Everything's impossible before it's possible. So pretty much in all standard and code, there is an opportunity to present something that's an alternative and to prove through testing. And that's fantastic for anything that's disruptive and new and innovative. So what we're finding, I spend a lot of time talking to Department of Health, different regulatory boards, people that are, concerned about something new like this. And I am seeing, a turning of the tide. People are looking for these types of solutions, whether it's economically based, it's more viable this way, or really genuinely sustainable and innovative focused. I'm seeing more openness to alternative disinfection, and I think that's only going to grow with these pilot projects essentially that are opening up and showing their effectiveness. A really cool tool that we have that's kind of adjacent to our industry but still similar to this conversation is our Alpha mobile unit. We actually have an entire treatment plant on wheels. Alpha mobile unit, essentially, we're able to drive it right up to a wastewater treatment plant, take that water that's usually released in a stream and clean it to potable grade drinking water right there on site. So with that, there's a lot of other positive benefits, like being able to prove testing on site, and lab results to just show, these policymakers and these regulators that, hey, we're actually exceeding the standard that you have here. Look at how we're doing it. See it, taste it, which is a really great tool for us. I think that's helping open up the minds and push progress faster.
For sure. No, I think it's really exciting. The potential to use wastewater, even stormwater that's currently being wasted in surf park environments, to me is going to be pretty clutch for having them approved in drier environments, and to make use of a resource that's currently not being utilized is pretty exciting stuff. So thank you very much, Jessica. It's been a really interesting chat. I consider myself greatly more informed than I was before we started it. So thanks again for coming along today.
Thanks for having me. I'm excited to chat about it, and really looking forward to Summit here in the next couple of weeks. So appreciate it.
For sure. Just where can people find out more about water if they're interested in taking the next step?
So we have a really tremendous marketing team, and we were able to achieve a trademark on an untrademarkable word, water. We spell water with 2 V's instead of a W. So if you go to www.VVater.com, you can learn more about the different verticals that we're in, learn a lot more about our technology. We are on social media as well, LinkedIn, Instagram. We're going to be doing a really cool education session at the upcoming summit where I can show some great visuals of the LTEP process. We can talk about some more case studies as well. So if you aren't able to make it, check us out online. There's a lot you can learn there. You can also just get a hold of me through a number of methods. I'm very available to sit down and chat with you or attend the summit.
Excellent. And your summit presentation will be video recorded and made available to people who are members of Surf Park Central as well. So we'll catch it there. Thanks again, Jessica. Really good to talk to you.
Great to talk to you as well, Jess. See you soon.
Okay, bye.